So one of the terrestrial worlds we need to talk about is the Earth. My slides actually kind of start out talking about all of the terrestrial worlds. By terrestrial worlds, I mean the 4 inner planets, okay? And moons are kind of little mini terrestrial worlds. A moon, yeah, it's rocky. The difference is the moon doesn't orbit the sun, the moon orbits a planet. Okay, so quick comparison. Let me kind of pull up some lights here. Kind of from left to right, how they are. Actually, on your Unit 2 exam, one of the questions I'm going to ask is the order of the planets. So we've been kind of working on that, right? My very educated mother just served us 9 nothings. So that's how I remember it. Long time ago, my very educated mother, of course, mother is Mars, Jupiter, just Saturn, served, I guess, you would be, what, Uranus? Us, nothing. Used to be 9 pizza pies.
Yeah.
But, yeah. Did you guys hear that Pluto, and a friend actually, church gave me this little article. They're wanting to bring Pluto back as a planet. I'm like, no! So anyway, so that's the order of the planets, and we're talking about these guys. These guys are terrestrial or rocky, same thing. And as we talk about the planets, kind of keep in mind, Chapter 6 talked about the birth of our solar system, okay? So kind of keep that in mind, too. This is kind of on surface what they look like. The video that we looked at, all it did was kind of talk about the interior of Mercury, which I thought was kind of interesting. I didn't realize Mercury had, this is my magnetosphere. This is my magnetic field around a planet. I didn't realize that Mercury has a magnetic field. But the way we know kind of the interior of planets is kind of the way we know the interior of our planets. Have you guys ever seen the movie, what is it? With the, what's that?
The core?
Not the core. This is like a funny one. Like they have like little critters underneath the ground. Is it critters?
Is it Tremors?
Tremors, yeah.
Tremors.
Oh my gosh. Tremors, yeah. So a tremor is like a ground shaking. And if you're a seismologist, you're like, oh, you're so on to that, okay? So you want to watch the ground shake. And you can actually, if you understand the source of the kind of energy that's making the ground shake, and you kind of get at 2 locations of the ground that's shaking, you can understand kind of the composition of what's on the interior, okay? That's the kind of how seismology works. And so from seismology, we understand our own planet. So the way this works, you're going to see all the planets lined up here, okay? And as all the planets, well, and the moon, are lined up, they're lined up in decreasing size, not in order from the sun, but this is getting the largest and getting smaller. So you can already see Earth is the biggest terrestrial planet, and Venus is Earth's sister. Then we have Mars, okay, and then we have little Mercury and the moon. So there's kind of similar aspects to these planets and the moon. The big silvery looking thing actually is the core. Yeah, the movie The Core. Great movie, too. The big silvery thing is the core. And we're going to actually, I have a slide coming up, but as it turns out, when all of these objects were kind of ooey gooey, kind of entirely fluid, it's kind of like things that are dense will sink, and things that are light will float. As it turns out, metal is dense. So it sank, yeah. And so for all of these cases, the cores are high in their metal content. A lot of iron there. And then you can kind of see the red color. The red color is the mantle. And if you're like me, you think mantle, you kind of think, well, maybe you do, maybe you don't. I kind of think volcanoes and liquid magma and mantle. But as it turns out, not all of the mantle is liquid, okay? It's not all liquid. That's solid. I think that's right, yeah. And then you can see the tan part. The tan part is the crust. Okay, so we have crust, mantle, core for all of these. We have a third thing called the lithosphere. I think the word's on here, lithosphere. For each one of these, we have a lithosphere. If you find the dotted line, that is the lithosphere. So the lithosphere takes the crust and part of the mantle. Okay, that's the lithosphere. The lithosphere is important if you're familiar, and we'll talk about plate tectonics. I don't know, okay. Basically, our Earth, and not all planets are like this, is kind of in slabs of stuff that kind of move on liquid underneath it, okay, plate tectonics. And those plates that move, think of that as that's the lithosphere. Kind of hard to say. Yeah, that's the plates. Okay. All right. So notice that all of these and the moon have the core, mantle, and crust, but they're not the same proportions. Like the video said, you know, Mercury, little Mercury, man, it got a whole bunch of metal and not a whole bunch of mantle and crust. Okay.
Well, time to mine out Mercury.
What's that?
Time to mine out Mercury.
Time to mine out Mercury. Don't have to tap too far before we hit those metals. Okay. So a minute ago I said, so what did I say was the most dense?
Metals.
That sank to the metals. Very good, yes. And that this slide is kind of talking about that. It kind of actually goes back to, remember in part 6 I talked about the nebula, the solar nebula. And I didn't talk about how it began contracting, but it probably began contracting by maybe a nearby supernova that kind of got the thing contracting, spinning, okay? Contraction basically converted potential energy to kinetic energy. Kinetic energy is motion. Sometimes that motion can exhibit itself in temperatures. So that's kind of how that's part of the solar nebular theory. But so the sun was heating up and so were the planets. So kind of, I talk about that snowball sort of we call accretion. Basically, the planets kind of clearing their row, you know. And I can't help it. I'm haunted by Pluto maybe coming back as a planet. Oh my gosh. Because one of the things in the little article I read was that they want to remove this criteria that a planet needs to have cleared its orbit, an object needs to have cleared its orbit as in its path about the sun in order to be classified as a planet. Because the article, and it's right, said actually if you look at the other planets have little crumblies here and there too. So why pick on Pluto and why pick on Eris? Just because they have stuff in their orbits. I don't know. So we'll see.
They got a lot more of it?
Yeah, they have a lot more of it, and I don't know.
Does the size have anything to do with it?
Well, it should. You know, the article's right. You really, size, I mean, Mercury's pretty small. We wouldn't demote it. I don't know. So this actually, of stuff sinking, is called planetary differentiation. Differentiation sounds like a big word. It just means different. It means you get that different. You get the heavy stuff at the bottom, and you get the light stuff at the top. That's planetary differentiation. I don't have a slide. Let's see what else I have on here. Okay. I don't have a slide, but if you can picture yourself taking salad dressing, but it has to be your oil and vinegar water salad dressing, like Italian salad dressing. Mm-hmm. Italian salad dressing. Okay, so mix it all up, and that's kind of what the planets started out being. What happens if you set it down? It separates, exactly. That's kind of like planetary differentiation. Kind of what falls down would be our metals to form our core. Okay, and what kind of floats up will be our light things to form our mantle and our crust. Okay, so kind of salad dressing is planetary differentiation. Italian salad dressing. Okay. So this, remember I said there's some dates that you need to know, and one of the dates is when our sun began, what's that? What?
Solar wind.
Blowing? It's my solar wind, exactly. That's my solar wind. So when a star turns on, it begins its own little stellar wind. In our case, it was solar wind. And our sun did that about 4.5, 4.6 billion years ago. Okay, so now I have a slide, and Jay and I were just talking about this to kind of say, is a planet geologically active? Now here on Earth, if somebody says Earth is geologically active, which it is, what do you think of?
Hawaii?
Think of Hawaii. Very good. Why Hawaii?
With all the lava that's coming out?
Because all the lava that's coming out. Geologically active Earth means volcanoes. It can also mean actually earthquakes. Yeah, very good. okay? So geologically active planet. So, I'll just go ahead and put this up here. So here we go. Here's our order from largest to smallest again. Now here's one for you. What if you were, let's see, I know, we just had pizza the other night. What if you were to have a whole, piping hot pizza? Okay, here's my, oh my gosh, I brought pizza for lunch today too. So we have a large pizza here, hot out of the oven. I'm gonna take a piece of pizza and I'm gonna put it over here. This is an experiment, I can't eat it. Okay, I know, not yet. Okay, and I'm just gonna sit back and I'm gonna watch them cool down.
Oh,
I know.
that's
Well,
torture.
it is. Okay, which one's gonna cool down fastest?
The one by itself.
This guy's gonna cool down fastest. It just is. He's got kind of more surface area, he's got less mass, he's got less heat associated with that smaller one slice.
Yeah.
This is gonna cool down more quickly, you're right. Just so actually, these objects, and I've got Moon, Mercury, Mars, Venus, Earth, these guys down here are gonna cool down more quickly. Exactly. And as they cool down, then you don't have your liquid mantle and liquid part of your liquid magma in your mantle to come up and be your volcano or whatever. So that's kind of a big player in whether it's geologically active or not. And this is where I was talking to Jay about this, and a few years ago, I don't know how long ago I prepared these slides, but I actually tried to track this down. Which of these planets, from largest to smallest, have liquid mantle, okay? Have liquid stuff in their center. And as it turns out, actually, it was active in the past, okay? But the moon is geologically dead. Okay, I mean, it's okay, it's fine. Okay? And Mercury, geologically dead. They just cooled down, to the point that they solidified. They haven't always been that way. Actually, we see features on Mercury and features on the moon to know that they used to have liquid underneath their crust. Starting over here, the large ones, okay? The Earth, you guys told me, geologically active. You're totally right, okay? Venus. Now, when I talk about Venus's geological activity, it's going to be this strange sort of thing. We actually see kind of, through the clouds, we can see that Venus's surface actually has kind of, looks like old volcanoes. And it's thought that it doesn't have your normal ongoing volcanic activity, that basically its crust every, I think it's 700,000 years or so, the whole crust melts. It liquefies, and then it solidifies again.
Why is Mars a question?
Mars is a question mark because it seems like, with regard to its size, it seems like it might have not cooled down enough and might be liquid, or it might have solidified, and we're just not sure. So when I looked it up, it's a question.
Okay, wow.
So that's a good place to stop. So we'll pick up here on Wednesday. Did you have a question, Ted?
No, I just said more nukes at the center of Mars.
More what?
More nukes at the center of Mars.
No.
Let's get things started
Where's
up
planetary protection?
again. I want to get things started again.